In this challenge question, we're going to take a look at a recursive function that does a little bit of work after a recursive function call returns. What do I mean by this? Well, specifically, if you notice, this is a function named f, and here's our recursive call, right? And so this recursive function call here, notice we're printing something after that recursive call returns. In other words, this line is going to print, the result of calling f of n is whatever this result was computed. And so this is going to force us to be a little bit extra careful with how we keep track of our stack values. However, this is a very simple example of a recursive function. We're not even using a recursive structure here. This is just a sort of a trivial little summation of how do you sum from 1 to n. In this example, from 1 to 3. So that would be 1 plus 2 plus 3 is ultimately what we're doing. Again, very trivial, but an important phenomenon plays out when we see that, okay, our recursive function call happens, but after that returns, we've got more work that we do before we return back to another recursive call or ultimately to this level. So you should have all the tools you need to follow through this. This is the same rules you've been applying and learning throughout this entire course. I want to give you a chance, and I really encourage, I'm pretty confident you'll be able to knock this one out of the park. So pause the video here and give this a shot. All right. So let's step through, and I'm going to start, I've already, as you can see, fast forwarded to line 3. We've got the output of entering f where n was 3. And we reach this test, is n less than or equal to 1? Well, in our current frame, which I'll try and keep a habit of, keeping track with this red dot here, the red arrow is what we've used in the past. I'll do the red caret. That's our current frame. And of course, n is 3 here. So how do we move forward? Well, this is false. So we move our evaluation down to the else statement. And here's where we reach our recursive call. And we're setting up a variable named result. So I'm going to go ahead and make some space for that in my frame. So we need to keep track of this local variable result. And what is result going to be? Well, we need to evaluate this recursive call, right? We don't know what to substitute this with. So we call f of n minus 1. What is n? N is 3, n minus 1 is 2. So it's going to be the same as calling f of 2. So we need to set up our frame for this, right? So we push a new frame. For f, this is a recursive call. The return address is line 7. That's where we go back with the result. This time around, n is 2. Right? So our current frame is actually moving. Our current frame is now the lowest frame on the stack that is yet to return. So of course, that's this one. And we jump into this frame. And what do we do? Well, we reach this print statement. So we entered f where n is 2. Okay, so I'm going to write that down. Enter f where n is 2. That's evaluating this very first print statement. And then we test, is n less than or equal to 1? N is 2 in this frame, so no, it's not. We go to the else. And here we need to set up another result variable. So our result variable is not initialized yet. We need to go and figure out what is the evaluation of this expression. Well, this time around, we see we've got another recursive call to complete, and n is 2, so 2 minus 1 is 1. So we need to go compute what is f of 1. So this is a full function call. We push another frame here. And so f return address is line 7. And this time around is 1. And we jump in. And we see that we're going to print enter f1. It's the very first thing that we do on line 2. Right? So that's our output. And then we test, is n less than or equal to 1? Yes, it is. Right? So we've reached our base case. And remember, this is our base case because we do not have any recursive call here, right? So this is our base case. We're just going to return none. But first we have to print this out. So what do we print out here? Well, we print out f, open parenthesis, and then we substitute n. N in this frame is 1. And then we are just returning n because that's what we're returning here. So return n. We're indicating that we're going to return 1. So that's going to be 1. Right? And again, that's this substitution here and this substitution here are where the 1 and the 1 came from. Well, we reached the return statement on line 5. So we enter, oops, and I didn't update, I'm sorry about that. I didn't update my current frame. Of course, my current frame is always the lowest on the stack. That's why n was 1. We had not yet returned. Notice this frame doesn't have a result variable because we never initialized it or declared it through its execution, but we did reach this return statement. And so this return statement says we're going to return n. Well, what is n? N in our current frame is 1. So we're returning 1. Where are we returning 1 to? we're returning 1 to line 7. Right? But before I process that, let's enter the return value here. This returned 1 to line 7, and that means this frame is done, and our current frame then returns back to this frame where n is 2, and we just substituted in, for this expression, f of n minus 1, this expression resulted in the return value of 1. We know that n in this frame is 2, right? So 2 plus 1, and again, this 2 comes from this n here. Our current frame n is 2. Right? 2 plus 1 is 3, so our result variable is going to be initialized to 3. And then we continue on, and we reach this print statement. So we print f, and we look at what in our current frame, what is n? N is 2 in our current frame, is resulting in, and then we substitute in result. In our current frame, result is 3. Cool. And then on the next line, on line 9, we are going to return result. When we look in our current frame, our result is 3. So we enter our return value 3 here. Where are we sending 3? We're sending it back to line 7. So line 7 here. So this is going to be 3. But notice that our context changed because this function call finished. We now return back to this frame. Right? So we're now on line 7. We've returned back to that function call. We returned 3. And in this current frame, when we ask ourselves what is n is 3, right? Because our current frame, n in our current frame is 3. 3 plus 3 is 6, so we initialize 6 to result. So result is going to be, oops, let me switch to black here, 6. And then we've completed line 7. Now we continue on to line 8. In line 8, we're printing out f. 3 is, and then we substitute in result is 6 in our current frame, right? So result in our current frame is 6, and was 3. And then we reach line 9, and line 9 says we're going to return result. So result is 6 in our current frame. What are we doing with 6? Well, let's enter that into our frame so we know that it's done. So return value is 6. We're turning it back to line 11. Line 11, we just called this function. We didn't print it out. We didn't print its value or anything. So at this point, our current frame would have returned back to the stack or globals, and we'd be done. So this program would exit, and this would be our output. Now, what I hope is interesting here is notice what's going on, right? This pattern is playing out in an interesting way. We initialize this call with f of 3, right? 3 led to this call where n was 2, led to this call where n was 1. That was our base case. And then we returned 1, and then we returned 2 plus 1, and then we returned 3 plus 3, right? And so we can kind of see that when we have a recursive process play out like this, as we enter each new recursive frame, we go back in the order we came from, and we return back to that context where we had the state that we had before. And that's what gives us, the output that we see here, where we enter F3, enter F2, enter F1, and then F1 returns 1, F2 returns 3, F3 returns 6, and we work our way back out. Right? But notice that these are paired in this way, and it's kind of like, if you started on the roof of a building, and you went down the stairs, and then you needed to go back up all the stairs, right? You go from your top floor to the next floor below it, to the next floor below it, until you reach the ground. And then you would have to go back in the reverse order. And so this type of result can be kind of surprising where, the prints that are happening before a recursive call are in order as we're working our way down, in this case, because we're subtracting 1 at each of our recursive steps. But after a recursive call, when we print following a recursive call in that same frame, before we return from a frame, we work our way back up in the opposite direction, right? We haven't yet finished that frame, so we're still in 1, boom, and then we're still in 2, boom, and then we're still in 3, boom. And again, the general sense is we go like this, right? Where our calls lead to setting up our parameters, setting up our parameters, setting up our parameters, and then when we reach returns, we go back, we go back, we go back, right? And ultimately we go back to the globals. This is how the example that we just followed, doing a recursive directory traversal worked, and why we saw that we would enter a directory, we would go see all of its children, we would enter a subdirectory, we would go see all of its children, we would exit that directory, and then ultimately we would exit the very first directory that we entered. Same idea at play here in a simpler example. Great work tracing through this.